All right. So let's talk about this. Item number 1 on the agenda. There is a small algebra type quiz that's on Schoology. Just opened 10 minutes ago. So take a look there. And that'll be due Friday night at 11:59 p.m. So I would imagine it would take no longer than 10 minutes, where 6 of those minutes is you getting your computer to turn on. So that's good, right? 2 minutes. 2 minutes. Yeah, it's pretty quick, pretty easy. It will lead us towards, so we're doing finding solutions. It's a lot of quadratic stuff, using quadratics and vertical angles a little bit. I think it's very good, it's very fair, and it actually leads us towards things that we're working for next semester on solutions that you might solve that don't actually work, which are called extraneous solutions. So those are just some things that we're just trying to lead you guys and girls into. But today, theorems about isosceles and equilateral triangles. Isosceles, help me out. Angle side theorem. Good. What is an isosceles triangle?
Two sides congruent.
Two sides congruent. Does anyone else know anything else about an isosceles triangle other than two sides congruent? Ooh! I'll say two base angles are congruent.
Nice job, buddy. Thanks, man.
All right. So isosceles, you have two sides that are congruent, and you have the two base angles that are congruent. Equilateral, what do we know about that?
Everything's congruent.
Everything's equal. So 60, 60, 60, and all sides are the same. Develop an understanding of the theorems that result when analyzing isosceles and equilateral triangles. All right. Let's see what we can do. Is there a proof? Is that the next thing? Oh, yeah, we're there. All right. Let me take care of the hard part. So step 1 will go AD is congruent to AB. 2, C is midpoint of BD. So we got a given, and we got a given. All right, let's see. We have only seen this triangle about 45 times so far this year. So let's see. Somebody who normally doesn't answer. Pick on. Sammy. Sammy, what do you think I could say as a result of any of that?
Say AC is equal to AC because of the reflexive.
I would agree with that. AC, so reflexive properties sticking out for us. I like it. Good job, Sammy.
Nice, dude.
All right, reflexive property. That totally works. So we know that. And then we also knew that AD here and here. Okay. Oh, I guess I should put a triple mark there. Well, no, we can't get there yet. Case.
Oh yeah, sure.
I would say that line DC is congruent to line CB because of definition of midpoint.
DC is congruent to CB, definition of midpoint. Yeah. So it'll be a single tick. Okay. Can I prove the two triangles are congruent?
Yeah.
Yeah? Why? Side, side, side. So number 5, I can go ahead and say that triangle ADC is congruent. Yeah. We are. We will get there. ABC. So ADC, ABC, and we said side, side, side. Hey, why did I have to put step 5 and I couldn't go right to letter D or the proof? Yeah, Don.
Because you need to use CPCPC, but you need to prove that the triangles are congruent first. So if the triangles are congruent, then you can't use CPCPC. So if you can't use CPCPC, then you can't use the proof, and you can't prove the proof.
I love it. I followed all that. That was awesome. All right. So this was an error. If you had made an error on the quiz, this is where the error would have taken place. Like for step number 5, you would have given me the reason being CPT, CTC, and it's like, no. Triangles have to be proven congruent in order to get there. I also had students telling me like angle D is congruent to angle B because of side, side, side. No. It's the CPCTC. The corresponding parts of congruent triangles are congruent. And you all want to know how many of you got the CPCTC definition right? There wasn't one person in here that got it wrong.
Hey, no.
I found a dime. This is 10. Did anyone lose a dime?
Yeah.
If so, can you describe it? Can you tell me what the date on it is?
1977.
77.
You're wrong.
1999.
67.
2003.
2015. But you guys were all close.
2005.
All right.
What?
2015.
All right. That's proven, yes?
So,
We're good? I will tell you, I was pretty nice to you on the quiz because you know how some of the places we had things filled in, like we'd have this and this and this filled in for you. I gave the points, so I would have said this is a 12-point proof, even though I had like 3 of the points for free. So I gave you some points for free. So for the person who left it blank, you know it is. What is our definition of an isosceles triangle? So we just said it. What's isosceles? Two sides congruent. Let me ask you all this. This proof back here. Is this, ooh, let's do crayon. Is this the purple triangle here? Do you feel it is an isosceles triangle?
Right?
What is sticking out right now to say that?
Two sides.
What 2 sides?
AB and AB.
AD and AB are congruent. Now, what did we just prove on this? What did we prove? What was our big proof?
D is equal to B.
Yeah, angle D. So this angle here and this angle here, let's make a different color. Make it that yellow. Make it a bright yellow. So we just proved those base angles are congruent. Is that an isosceles triangle as it sits? Yeah, we have to have an altitude in it or all these other things, but those base angles are congruent. So no matter what type of scenario I have, this can be proven because isosceles triangle not only has the sides, it has the base angles that are equal. So that's we're doing proofs like crazy. All right. Let's see. Definitely. Oh, let's see. We gotta pull this out. Is this something? Oh yeah. Oh, where does this go to? Oh, there we go. Oh yeah. Fancy. Congruent sides. So those are the legs. Third side is the base. So the side that's not congruent to the other 2 we'll call the base. Angle opposite of the congruent side are called the base angles. Angle opposite of the third side is called the vertex. So base angles are equal. Legs are congruent. The side that's not is called a base. And the angle that's opposite of the base is going to be called the vertex. Make sense? Yeah. Like it? Happy? Can we move on?
Yeah.
No? Sorry. Is that a yes or no? Oh, theorem 4.7. If blank sides of a blank are blank, then the blank blank, those blank sides are blank.
Blank.
if 2 sides of a triangle.
Okay, let's see. If 2 sides of a, no, we don't. I bet you we're going to say isosceles. I'd say that should be if 2 sides of a triangle are congruent. All right. Then the
Base.
say it.
Base angles.
That's what I said.
Base angles. Okay. Bless you.
Of those layers.
Of those
Those
sides are congruent.
2 sides.
of those congruent sides are congruent. Is that right?
Yeah.
Does that make sense? If 2 sides of a triangle are congruent, then the base angles of those.
Congruent sides are congruent.
I don't know.
Base angles
No,
of those
yeah.
2
Yeah.
Maybe 2 sides, maybe.
No,
Two
that's
sides.
Well, it's the
Whatever.
same thing. Either way.
Okay. As long as you make it work. Hey, we got a star here. See what the star says. If that's all it says. Take a look. If congruent sides, then congruent base angles. Okay. two congruent sides, then the base angles are congruent. Oh, I'm so excited. We're on isosceles triangles.
I love this one.
Ooh, the Converse. That sneaker. That type of shoe. Chuck Taylor's.
Just kidding.
What about the Converse?
It's that base.
Oh, so if the base angles are congruent, then
The sides
the sides are congruent. Okay. So if the base angles are congruent, then the opposite sides are congruent to those angles. And something that we need to look into the future about. This is the opposite side to that angle. This is the opposite side to this angle. And that's going to help us when we hit trig, when we start talking about opposites. Anyone know what the angle that, now we're not going to get there, because then we don't have a right triangle up there. Anyone know that? I bet you might know this. You know that a triangle is the sturdiest if it's shape? So if you were to walk into the attic of your home, unless you have a flat ceiling home, if you go up the attic, you see triangles in there. And the triangles aren't because they're trying to save wood. It's structurally very strong.
Because I guess the two sides are dependent on each other. The weight, right? And squares more or less.
There's a couple of really cool theorems that you use, and when you guys and girls get to physics, and you've taken enough math, here's the funny thing. Conceptual physics is a wonderful class. But when you get to physics that has the math applied to it, it's so awesome. But that's coming from a math guy too. So conceptual is like, oh, okay, I'll take that. But then you prove it mathematically, which using law of sines, law of cosines. Ooh, theorem 4.8. If I bet you, if base angles of a triangle are congruent, then the
Then
two
the
sides.
opposite sides or two sides or something like that, opposite sides of those angles are congruent. Like that. That's congruent. Which I bet you this is going to be an unbelievable graphic. Oh yeah. If base angles, then sweet. If. Hey, what did IFF mean? If and only if, and that means what?
By conditional statement.
It's a biconditional statement, which means of the four things, everything is true. Good. If it's not biconditional, and the statement is true, then what else has to be true? So which one? No, not the converse, not the inverse, it's the contrapositive. But if all four are true, then you can use it, make it biconditional, and say if and only if. Okay, what is our definition of an equilateral triangle? What do you think? All sides equal. Okay. All sides equal.
And angles equal.
All angles equal or congruent? What do you think? What else do you think might be true about an equilateral triangle? Any ideas? Does that look about equilateral?
Yeah.
So far you've told me this, and this, and this. Anyone else know anything about that?
You say it's like all the angles. It's kind of the same thing. Like all the angles are 60 degrees.
All the angles are 60 degrees. I like that as well.
All the exterior angles are the same.
All the exterior angles are the same. I'll take that as well. So I'll mark that. as we get further into math, you're gonna put an altitude in there, which will cut the segment into 2 equal parts like that. And this actually creates your 30, 60, 90 triangle, which that leads us to a whole bunch of cool stuff. Yes, Pythagorean theorem would work here, but if you knew each side being x in length, then this would be x over 2. And there's a relationship between these two. This would be x square root 2, or x square root 3 over 2. Which that leads us into trigonometry, is pretty fun. If you like this stuff, you'll love trigonometry. Best class ever. Now let's get a second to this though. We could use the isosceles triangles theorem to prove 2 additional theorems. If a triangle is blank, then it is, I don't know, what do you think? And if so, if a triangle is equilateral, then it is equal. I don't know.
Oh wait, never.
What if we said equiangular?
Angular, yeah.
That's spelling right?
It is equilateral.
Yeah, it is equilateral.
Yeah, like that.
Then if a triangle is equilateral, then it is.
Angular.
Alright, we can make that work. Then it is equilateral. Sweet. So those are the converses. Being those are both true, then I'm sure 4, 8, and 4, 9 could have been put together to make a biconditional statement.
Yeah.
Oh yeah, but we don't have to. Yeah.
So if we're doing a proof and we're using that as a reason, what would we
I wouldn't necessarily put 4, 8 or 4, 9. I would put equilateral triangles have this, or equiangular, or all equilaterals. Ooh. Alright. We got a few dabbers in there. What do you all think x would be equal to and y? What do you think x would be equal to and y? Emma.
7.
Why?
Because it's an equilateral or angular triangle.
It is an equiangular, so it should be equilateral. I agree. I think this should be 7.
Oh, I got this.
I like that. I like that. Okay. So, being that these angles are the same, that means all of the sides have to be the same. So, what would this side here that's not labeled have to be?
Yeah.
7. And so notice that's 7 opposite of this angle. And is what do you know about this angle and this angle? They're congruent. So what would you know about this opposite side?
Congruent.
So it would have to be 7. So I know that y plus 4 would have to equal 7. So y equals 3?
Yep.
Cool.
Wait.
Smart, Phil.
I'm so proud of Phil.
I know.
Everyone's proud.
Another one.
Hey, Phil got an A on that last test.
Yeah, nice job, Phil. Nice.
There's more you want to teach the rest?
No, this is lots of fun though. I enjoy this. I was a math teacher too, so
Same.
Don was too.
In my past life, I was a math teacher.
Alright. Yeah, buddy. See you soon. Alright, example 2. I already did. Example 2.
He's going.
He's gone. Alright.
let's do it.
Break out the ice cream. Alright, what do y'all think?
X is 40.
X is 40. We have a call out that X is 40 here.
I agree.
What do you think?
I agree. Because 100. Wait, no. Wait, no. Yeah. No. Yeah. You're right. Never mind.
So let's ask this. Let's ask this. So this side goes to this angle. This angle goes here. This angle would also have to be what? 40. We know that the three angles added up should be what?
180.
180. Okay. What does this form right here? 180. So how big is this angle right here? 80. And my opposite side is congruent. So what does this side got to be? 80. And 80 is?
160.
So y must be?
20.
Done.
Good job, Phil. Good job, Phil. Thanks.
Bill got this one again? Didn't get it again.
Phil's just on top
Uh,
of it.
what do you think? Is this easy?
Yeah,
No.
It's logical thinking once you know the rules of an isosceles triangle, I think. But the linear pair kicks in there nicely. Oh, yeah. All right, let me put the obvious. Let's figure out the rest. Angle 1 is congruent to angle 2. And EC is congruent to DB. And I got a given. All right, angle 1 is congruent to angle 2. EC, so here to here, is congruent to here. Okay, so let's start using some knowledge of an isosceles triangle. We wanted to show that AEB, that's the wider of the triangles, is isosceles.
Oh, angle 1 and 3 are supplementary.
Okay, I agree. I like that.
Linear pair.
Linear pair. So angle 1 plus angle 3 and angle 2 plus angle 4 equal 180 degrees. It's linear pair. Okay. Could we then state that? Okay, could we skip a whole bunch because we are obviously see the logic? We can go to saying that angle 3 and angle 4 are congruent. I mean, if I didn't, I would say, okay, well, let's set those equal to each other. Then we'll sub in angle 1 into angle 2 or something like that, and then we'd be able to prove it. But I think we could make this jump right here. Angle 3 is congruent to angle 4. Bless you. Congruent parts, I like it. Congruent parts. But congruent parts is not CPCTC, right? All right. Any thoughts? Do what? AD equals what? Oh. ED.
Segments of Chapman property.
Okay. I like it. There's something that I think that we could have seen because we just proved this. And not that your order's wrong, but I wanted to just jump to this. AD, AC. Why can I say that? Why can I say that this and this are congruent?
Base angle.
Base angles congruent. So, definition of what? Or what kind of triangle? Isosceles. Base angles are congruent, therefore the legs have to be congruent. So that's going to lead us along to side and angle. And I think we do know that this whole thing, reflexive's got to be in there. For 6, DC is congruent to itself. That's reflexive. And then we could state that ED is congruent to CB. We could have easily said that ED plus DC is equal to EC. We could have said that BC plus CD is equal to BD. Then we could have substituted and subtracted and found easily with the reflexive. But I think we have congruent parts here. That's going to work nicely. So now this and this are congruent. I'm almost there. I think I have to prove that triangle ADE is congruent to ACB because of what?
Side angle side.
Side angle side is right. ADE is congruent to triangle what? ACB.
ACB.
What is it? A what? CB?
Good job, Phil.
Because of side angle side?
Yep.
And that's going to allow us to say that number 9, angle E is congruent to angle B. Why?
CPCPC.
There you go. CPCTC. And then step 10, we could even state that
You have to say AB equals AB.
AB. I'll just say that triangle ABE is isosceles. And then the reason I can say this is because base angles congruent. Done. So that's a nice 20-point proof.
Go down. Okay.
Woo! That was the first of many proofs today, isn't it? We had like 19 others. What do we have? We only got one more?
But that's the one from the
Do
notes.
what?
It says on the
Oh, okay. So if you want, you can get your homework sheet out, or we can just write it there. And if you skipped one on your homework because it was done on your notes already, that's also okay. I don't know. It's the one that looks like the very last thing. Let's see. Can I go forward? Now let's work one from your homework. Okay. All right. HK and JM. And let's just start proving stuff off of this. What can we conclude off this? What can we conclude off this? Just from what that first step, what can we prove? Is JK shared?
Yeah.
So I have reflexive. And if JK is shared, being reflexive, if that's shared, and this is congruent to this, and this is shared, what can we conclude? There you go. HJ and KM, good. And that's just congruent parts, right? And that's kind of our go-to answer. I don't know if it's the official good go-to, but I understand it. All right, so I'm going to go ahead and mark this off. This and this are good. We already knew the long thing, so let's see what more of the givens tell us. GJ, JK, wait, GJ is congruent to J. That is congruent? Okay. I don't know if that's going to help us. Did I say that right?
Yes, that's gonna help us because we can prove the triangle can be side and side or side to side.
GJ and JK are congruent. That's a given, right? But that's kind of a weird one. It's like GJ, so it's this, right? And JK is this. Okay. Oh, and then DK and JK. Oh, okay. So DK is congruent to JK because that's also given. And what can we conclude off of that?
DK drifting.
What is it? Can I say GJ and DK are congruent because of transitive? Good. GJ is congruent to DK. That's a little transitive property in there. I don't know if we needed that or not, but it seemed good. Holy moly. GJ and DK are perpendicular to HM. Okay. GJ and what? DK are perpendicular to HM. Given. So that's going to go with this and this and this and this. That's definition of perpendicular. I don't know if I have to go. FHM. FHM. That's the big one. Oh, Nikes. Oh, hey.
Side angle side.
For what?
For the triangle.
G, J, H, and
There you go.
J, M.
So highlighter here, right? This triangle and this triangle are congruent.
Side angle side.
Oops, side angle side. All right.
New crayon.
So that's HGJ. HGJ MDK. There you go. Because you told me what?
Side angle side.
It's side angle side. Okay. And then we can say that angle H is congruent to angle M. CPCTC, because we've proven it. And being that those are base angles, that will tell us that FHM, triangle FHM, is isosceles. Base angles congruent. Done. Sweet. All right, so where my mind starts going with a lot of this is if you list all the givens all together and then start going back to concluding, you might miss out on something. If you take an individual given and then prove things from that, even though you might overprove something, I think it'll allow you to start working through these problems. And again, it's just that logical progression. But if you're the person who needs to have all of your givens listed first and then start going from there, that's also fine. But just please be aware that there's multiple ways you can run through these. Okay? Feel good? All right. What, I don't even know what our homework is. Anyone? Any ideas? Watch. 4.7? Is that it? All right. 4.7. All right. So worksheet 4.7. It's a front and a back. And also, I had told you all that there's something on Schoology, right? It has, like, it says algebra review or something like that. So, we got, what, 15 minutes left?
No.
Does anybody, something like that? Close? 10?
Can we use the Chromebooks?
If you want to do Chromebooks, I'll open them up. Or do you want to